So in this next video, we're going to look at some of the energy pathways configuration options. Here in the scenario builder, we are back on the cases tab, and we're just going to run through these input configurations one by one. So the first thing is the run name. This is important. It's going to set up a folder name under which the rest of the files, including the runs key and configuration and the outputs, get organized. The next section here is going to give you some of the basic kind of temporal inputs. So current year, that's going to be the first year that the model is outputting results. The end year is going to be the last year that the model is outputting results. It will output results for every year between those two. Weather years here is used for selecting between different electricity and other shapes for the output. So if you have multiple weather years in your inputs, you can choose one or multiple weather years here using this configuration option. If the data supports it and I want to have multiple weather years, I can just put a comma and add an additional weather year there. Finally, the shape output time zone is going to be in the output files what time zone the shape reflects. The next section here is going to give some basic geographic information. So your default geography map key, this gets used in either upscaling or downscaling data when no other kind of data map key from the spatial join table is specified. So in this case, total population is the default in this example for Australia. The demand primary geography, this is going to be the kind of geographical breakup of my zones over which the model is running. Primary subset, this is, I would say, kind of an advanced feature that allows you to just choose a subset of the overall primary geography in order to output the model or produce model outputs just on that subsetted geography and not on the entire geography. A breakout geography is also kind of an advanced feature where what it would allow you to do, if I was working in the Western US, for example, and my primary geography was electricity interconnections for the whole US, I'd have, the Western interconnect, Eastern interconnect, and ERCOT. Say I wanted to take the state of Colorado and separate that out, just the state of Colorado from those other three geographies, I could put a breakout geography of Colorado here, and that's going to, do WEC, the rest of WEC, Colorado, ERCOT, and the Eastern interconnect. This Boolean flag on including foreign JUs, true, false, this basically tells the model whether or not to take database inputs that override certain geographies and to use those in the model calculation. So by default, we just leave this to true, but you can turn this to false, and this could be a helpful debugging tool. Finally, the disaggregate geography or disag geography. This is when you are doing some of the mapping with underlying demand drivers. It can be helpful to map those demand drivers to finer levels of granularity than the underlying output geography. So basically that is an option that helps preserve some of the granularity in the input data set. Finally, the disaggregate breakout geography, another advanced feature that is kind of the analog to what I mentioned above. So that's the geography section. Next down, we have units. This is all just basically specifying the output units for the model. So we have an energy unit, a mass unit, a currency name, a currency year, and then an inflation rate. So each of these are going to control aspects of the outputs that you'll see in the resulting CSV files. Finally, the demand output detail also relating to the outputs. So this basically tells the model which additional columns or what detail to add or keep in the outputs when it produces them. The reason that, at times we take some of these and make them false is simply to cut down on the size of the files. So, keeping a technology vintage in addition to every technology year, can multiply the size of your file by, 40 times. And so unless you specifically want to look at vintage as part of your outputs, this might be one that you just keep false. Finally, down here, we have output hourly profiles. So this tells us for the different final energy types, whether or not true, false, whether or not we want to output these, and then again, which years we want to output them for. You can put every year here if you list them all out, but again, this is just to cut down on the output file sizes. And moving past the demand output detail, there's a final kind of category here, which is to use service demand modifiers. These service demand modifiers are basically additional data inputs that can they can, in the case of, say, take one example of heating equipment, specify that some types of heating equipment use more service demand than others. So this by default we keep true, but again, as a debugging feature, it can be helpful to turn this to false. Finally, at the bottom, we have some of the log details. So that kind of, as a quick overview, looks through all the configuration options. In the next video, we're going to look at the process of creating new scenarios and sensitivities here.